Hello students, welcome to today's session. In today's session, we are going to discuss the topic called as evaluation of. So it is evaluation of postfix. So we're going to discuss evaluation of postfix expression. Okay. Now, previously we have discussed the concept of infix to postfix conversion. So if I write any symbol like A plus B minus C into D. So this expression is in the form of infix. Okay, so we have an infix expression. Okay, now this infix expression I need to convert into postfix. So whenever I want to convert this into postfix, as we know, we'll be giving the precedence to the operators. So first precedence will be given for multiplication, so I'm going to get the postfix expression as C D into. Okay, next, when I see the other operators, we have plus and we have minus. And when I solve from left to right, the first we are going to solve is we are going to solve AB plus. So I'm going to get the next expression from the postfix as AB plus. Okay, and after that we'll have minus. So now this is our postfix expression. Now by using this table, I'm going to solve this postfix expression. So the expression will be something like this. We'll have the symbol. Next we'll have N2. So next we'll have N1. So next we'll have the value, and after that we'll have stack. Okay, so by using this table we are going to solve the expression. So before solving this expression, we need to understand whatever symbols that we are going to use, all those symbols are binary operators. Okay, so when I say binary operators, it is nothing but we are going to have two operands. So two operands will be specified for each and every kind of operator. Now, let us start the conversion from or evaluation of the postfix expression. So now, before evaluating, I need to know what is the value of A. Suppose A I am going to assign it as B, I mean 2, B I am going to assign it as some 3, C I am going to assign the value as 4, and D I am going to assign the value as, so I'm going to assign the value as say 6. So let us consider these are the values we have, the value of A, B, C and D. So when I write this given expression, this postfix expression, after considering these values, we'll get the expression something like this: 2, 3 plus, and we have 4, 6 into, and we'll have minus. So this is what our expression will be, something like that. So we have the expression like 2, 3 plus 4, 6 into minus. This is our postfix expression. Now I need to evaluate this expression. So if I want to evaluate this expression, we are going to read each and every character from this expression. So when I'm reading this each and every character, we are going to take the first character, which is 2. So now, according to this, the process of solving, whenever you see an operand, that operand will be directly added onto the stack. Okay, so 2 is an operand, so this 2 will be directly added on to what? It will be added on to stack. Okay, so when you see an operand, so operand in the sense whenever you see a numerical value or alphabetical value, we are going to directly add it into stack. Now again, second character what we have is 3. So again, this is also an operand, so we'll be adding it to stack, so we'll have 3 and 2 in the stack. Next, when I access the second character, third character, it is plus. When you see plus, so we are going to pop or we are going to remove two elements from the stack. One will be n1, which is 3, and other element will be 2. Okay. Now we are going to perform addition on these two values, that is 3 and 2. So I'm going to get the value or result as 5. So that result will be added back to the stack. Okay. Now once that is done, next we'll go to the next character, which is 4. So 4 will be directly added onto stack. So I'll have 4 and 5. Similarly, we have 6. 6 will be added into the stack. So I'll get 6. Sorry for that. It is 6 comma 4 comma 5. So this will be our stack after adding the after accessing 6. Now after adding 6, next we have one more operator, which is multiplication. Okay, so once you see the multiplication operator, we are going to pop two elements from the stack. What are those? First n1 will be the element that we accessed, which is 6, and second element will be, the second element we are going to get is say 4. Now so we are going to multiply these two values, that is 6 4s, I'm going to get the result as 24, and this result will be added onto the stack, which is 24 comma 5. 24 comma 5. So this will be our uh, say stack. So after that we have last expression, which is 5, that is say minus. So minus, I'll get the first value as 24, which is n1 value, and next value will be what we got as 5. Okay, so we are going to do n2 minus n1. When I do n2 minus n1, I'm going to write say 5 minus 24. Okay, in that case I'm going to get the value as minus 19. So this will be our final result after evaluating this given expression. Okay, so this is how we are going to evaluate any postfix expression. So for this type of problem, either they'll give you the infix expression or they'll give you the postfix expression, by using which, by using this kind of table, so where we are going to solve the expression. Okay, so the thing you need to remember is, so whenever you see any operand, so when you see an operand, okay, so operand in the sense the characters like a to z or any numbers between 0 to 9 or any digits. So when you see this, we are going to add those operands, we are going to add them to stack. Okay, so we are going to add them to the stack. Okay, if it is an operator, okay, so what we found, if it is an operator, when you found the operator, what we should do, we should do first function called as pop. So what we should pop, we should pop two values from what, from stack. So we are going to pop two values from stack. First value we are going to write it into n1, which is like value 1, and second value will be written onto value 2, which is n2. Okay, so this is the first step that what we are going to do. After that we are going to evaluate. Okay, so evaluate these two values by using operator. Okay, so whichever operator we got, according to that we are going to evaluate. If we got plus, I'm going to add those two values. If I had minus, I'm going to subtract those two values. So that operator will be executed something like this. If it is addition, we'll be writing n1 plus n2. If it is subtraction, we are going to do n1, sorry, it is n2 minus n1. If it is multiplication, we are going to do n1 into n2. Okay, if it is division, we are going to do n2 by n1. So these are the ways or how to evaluate the values. So based on the operator, we are going to use n1 and n2 value, by using which we are going to evaluate the given operator. After evaluating, we are going to add, or this addition is also called as push function. As we studied stack, push function is nothing but adding a new element into stack. So now, so this is also is nothing but this is push function. Okay, now, so add or push, what we need to add? We need to add the result. Okay, which result? After evaluating, after the evaluation, we'll get some result. Okay, that result should be added onto stack. So by following these two rules, the first one, whenever you see a operand, what we'll do? We'll add that onto the stack. The second thing, whenever you see a operator, what we'll do? We'll first pop two elements. We'll first pop two elements from the stack, which will be n1 and n2. Okay, so n1 and n2. After that, we are going to evaluate that expression, that particular operator. After evaluating it, we are going to add the result to stack. Okay, so this step will be continued until you finish all the characters from the expression. Once I finish all the characters from the expression, we are going to get the final result of our evaluation. So final result of our evaluation will be found only after evaluating all the characters from the given postfix expression. Hope this is clear. I'm going to stop this session here. In the next session, we are going to explain about how to solve, or how this algorithm will be, and I'm going to explain about programs also of both infix to postfix as well as postfix evaluation. Thank you.